Okay, we are gonna get started on week 2 of SQL. Thank you all so much for coming. I recognize some faces from last week. Quick show of hands if you were not here last week. Folks, okay, cool. Welcome. So what we're gonna do today is kind of a little bit of a review of what we did last week. So if you have a little bit of background in SQL, you'll see kind of the stuff that we ran through, or it'll be a quick refresher. And then we're going to get a little more advanced this week, which should be fun. If you haven't already, make sure you go to this link. It's also on the whiteboard and it'll be at the bottom of all the slides. You can grab the link to text from there, which I'll explain in a second. Welcome, come on in. Okay, so I'm going to go through just a couple of setup just to get us configured for today, and then we'll get into the meat of it. Okay, so like last week, this session is going to be very interactive. So I'm going to talk a little bit, I'm going to introduce a concept, and then I'm actually going to give you all a chance to go in and try writing that SQL query yourself. Okay, so be ready to be doing that. Hopefully that'll make this a little bit more fun. We're using the same tool we used last week, which is a tool called Hex. If you haven't used it, it's a super cool, easy way to use SQL and Python without having to download anything, do any setup on your computer. It's super great. I use it at work at my day job, and I'm happy to be using it here with you all. So if you go to this link, what you will get is a page with our project for today. It's going to give you this big long link to app.hex.tech. That is the platform we are using. So go ahead, sign into that. Make sure for your Hex link, make sure you're signing in with your USC email. So you can get into that. You might, depending on how you log in, you might get a prompt to select your workspace, choose the digital lounge one if you get multiple. All right. So you're going to this link, you're clicking on this longer link, you're logging in with your USC email, right? Once you're in Hex, you're going to see a bunch of different project options. You're going to be looking for something that says Spring 2025 Week 2 Data Modeling with SQL. That's what we are doing today, is data modeling. I'll explain what that is in a second. But what you should do is hit the 3 dots next to the Spring 2025 Week 2 and hit duplicate. Okay, essentially this is your little template kind of worksheet type thing for today. You're going to make a copy of that and do all your own query writing in that same template. All right, so go ahead and find Spring 2025 Week 2. If you don't see anything that says that, you can come into Hex and just hit the pink icon up at the top where it says Hex, and then you should be able to find it somewhere. I have a bunch of stuff from last semester, so mine's probably a little messier than yours. But you should see something that says Spring 2025 Week 2. All right. Okay, and then once you have your copy, you can name it anything you like. Okay, I'll do a quick run through of that again right before we start writing SQL, in case anybody missed it or has any questions. But just to kind of let you know where we're fitting into our workshop schedule. So this is our SQL and Python series. Last time we covered kind of a bit from the basics introduction to SQL. Today we're covering kind of SQL 201, if you will, which is data modeling, which I'm very excited to talk about. I do a lot of this in my day-to-day life. For the next 2 weeks, we're going to switch gears. We're going to not cover any SQL for the next 2 weeks of this workshop, and we're just going to do an intro to Python. I'll talk a little bit more about that at the end. It's another tool that's quite powerful. And then in the last week, we're going to kind of do a big review and put everything together and think about how you would use it in an actual project workbook. All right, so that's kind of where we're at in this overall workshop. All right, so what are we going to do today? We're going to do a quick review of everything that we covered last week, quick review of our SQL 101. So again, if you weren't here last week, you should be all good. Caught right back up with us. Data modeling is the meat of what we're going to do today. That involves a lot of joining data frames together. That's where a lot of the power comes from in SQL. So excited for you all to learn that. And if we have time, I think we should have a little time at the end. We'll talk about casting data types. All right, so to jump into a little bit of review of SQL 101. All right, if you were here last time or if you've ever written a SQL query, this should look pretty familiar. Any SQL query you write is going to start with select. You're going to be selecting from something, that's your table. And you're going to select from your table whether you want all the columns, a few columns. You can picture the table in your head like an Excel spreadsheet. All right. You may have, depending on your query, depending on what question you're trying to answer, a bunch of other pieces of your query. So you'll definitely have these two, and you may have one or more of these. You may be joining another table together, which we'll do a bunch of practice with today. You might be adding a where condition, which is where you're going to add your filters essentially. So filtering down your data by a set of conditions. You might be grouping your data. Okay, so you might be summarizing, say, by month or by year or by student, etc. Ordering our data, so sorting, right, alphabetically or numerically in either direction. And then limiting our data. Let's see if we only want the top 10 students by GPA, for example, we might limit our data to only 10 results. And just as a reminder, anytime you see SQL, docs online, often these words are written in all caps. You do not have to write them in all caps. I typically do not, totally up to you. All right, so just to run through the queries that we wrote last week. All right, these were a couple of the first queries that we wrote. Very first query we wrote looks like this. Select star just means everything in this case. So select everything from whatever our table is. Last week we were working with transcripts data and data relating to a TV show. This week we are going to be working with 2024 Olympics data, which hopefully will be kind of fun. So we just did a select star from. This was a large data set, so we added a limit 20, which just means the first 20 rows of that result. Okay, that's our very first query that we wrote. Here's a second one that we wrote, getting a little fancier. Okay, so we've got our select, we've got our from, but you'll notice we've added a few other things. All right, what we did here is we selected from our same table, our transcript data, but we wanted to group by our character. So instead of just selecting everything, we selected each unique character, and then we counted everything. So we counted every time that character appeared to get their number of lines. Okay, our data set was one row in the data set for each line spoken in the show. So if we count the number of rows that appear by character, we get their number of lines of dialogue. Okay, then we did a group by character, and we wanted to see who spoke the most. So the last thing we added here was an order by. Okay, order is sorting. We said we want to sort by, not alphabetically by character name, but we want to sort by this column, our number of lines. And our default sort is always going to be low to high, but typically when you're doing an order, you're often wanting high to low. So we added this keyword for descending, DESC for descending. All right, hopefully these look a little bit familiar, maybe starting to jog the memory a little bit. Okay. I want to talk about two other things that we looked at last week, and then we will get into some refresher practice to get the gears turning a little bit more. One of the other things we looked at last week was case statements. Okay, so very similar to the last query, we're selecting some information from our table. We're doing a count, but instead of just counting everything, we're counting in specific cases. All right, so here we're selecting season, episode number, the total lines of dialogue in that episode. And then we're counting two things in a specific case. We're counting case when the character is Elaine, then count the dialogue. So that'll give us the number of Elaine's lines in that episode. All right. And then secondly, count case when the character is Kramer, then count dialogue as Kramer lines. Okay, so same thing, but for a different character. All right. So the result that we'll get from this query is one row for each episode. So we'll have season 1, episode 1, total lines of dialogue, and then how many of those lines were Elaine's lines, how many of those lines were Kramer's lines. All right, so that's the type of thing that we can get to with case statements. All right, we scratched the surface of joining data last week. We're going to get a lot more into this today, but this is the join that we did last week. All right, so we had two data sets. We had our data set with our ratings of each episode. Okay, so a rating from 0 to 10 of how the critics or reviewers rated that episode. And then we had the data set summarizing our number of lines of dialogue. Okay, so we created this from that query on the previous slide. One row for each episode, how many lines of dialogue and how many lines of dialogue from a particular character. All right, so to join that together, so say we have a hypothesis that the more lines Elaine has, the higher rated the episode is, and we want to test that hypothesis. What we would do is join our data sets together, and we do that by looking for a common column. Typically, when you're joining a data set, you're going to want to look for a unique identifier, a student ID number, or someone's email address, something like that. In this case, we didn't have something like that, but we had season and episode number, which works as a combination. There's not going to be more than one season 1, episode 1 of a single show, right? So that works as a unique identifier. So we said select star, select everything from this table with this long name, ratings data with episode number. And then we have join. And then right here we have another just pretty standard query. Looks exactly the same. Select star from my other table. And then the very last piece of information I give a join is just which column or columns am I joining between? So what's the common piece of information between these two tables? I just need to tell it where to look. So in this case, I'm going to say join using season and episode number. All right, if this were something like email address, I would just have email address here instead of two things separated by a comma. All right, so that was our very first join. Okay, that was a lot. So we're going to get into Hex and do a quick just kind of refresher of where you're at. Okay, so hopefully when you got here, everybody went to this link and you have Hex open. All right, once you have your Hex doc open, you should have something like this, and you should have made a copy of it. All right, so you should have something like copy of, I made mine called demo. Okay, but it should say something like copy of at the top, and that's the one that you should be editing. All right, does anyone not have a copy of their Hex? Is anyone confused about how to get there? Everybody ready to go? Okay, cool. All right, so once you're in your copy of our doc for today, you're gonna wanna hit run at the top. That's gonna load our data. All right, so same as last week, there's actually a little bit of Python code at the top. That's what this cell is right here. I told you all we're not gonna cover Python today, and we're not. So I'm once again gonna skip over this. I will explain what this is doing at next week's session. So if you're interested in that, come to next week's session. For right now, just skip it. All you need to know is that we're gonna hit run, and this is gonna load our data, meaning we can access it from SQL. Right now, it's essentially like attached in some files. So running it is gonna load our data. All right, then I just have some notes in here for you of what I just talked through. So if you're more of a visual person, you wanna see it again, that's all here. This is just kind of how to set up a query. All right, and then if you scroll a little bit further, we have our first task, okay? Our first task is to write a few of those very simple queries. These are the same first queries we wrote last week if you were here. All right, so we want to write query to do a couple things. We want to write a query that gets the first 10 rows of our athletes data set, first 10 rows of our medalists data set. And then we want to write a query that'll get the number of rows in each of those data sets. Now, as a reminder of how to navigate Hex, all right, on the left-hand toolbar, you'll have an icon at the top that kind of looks like a stack of Oreo cookies with a lightning bolt. Okay, that's going to be your data browser. If you pop that open, you're going to hit data frames, and this will show you all of the different data frames or the different tables you can select from in this project, in this little notebook setup. All right, so you'll see the name of this table is athletes data. When I click on it here, it'll tell me how many rows, and it'll tell me all of my column names. All right, it's handy that it tells you the number of rows, so you can check if your query to count the number of rows is correct. All right, you have a built-in way to check who did that correctly. All right, so you're gonna write your query just in a SQL cell down below. As we move through today, you can add as many SQL cells as you like. If you hover between any two cells, you get this plus button. All right, and between your plus button, you can add, you're gonna be adding SQL, all right? You hit plus, you hit SQL, and you can add more cells. You can add as many cells as you want to your copy of the doc, all right? And write as many queries, you can write them in as many separate cells as you would like. All right, so as an example, my very first query to get my first 10 rows of my athletes data set, I'll go ahead and do this one with you all. So like any query, I'm going to start with select. In this case, I just want the whole row. I just want everything. Okay, so I'm going to do select star. You can be following along in your own copy. I'm going to do from, which I can do on the same line or a different line, up to you. They both work. And then the name of the table that I want to select from. So I'll double check the name of my table over here. I want that athletes table, which is athletes data. I'm going to start typing and it's going to try to autocomplete for me. So if I like the autocomplete, I'll just hit tab. Got me covered. If it's doing anything weird for you right here, just make sure it says data frames in the top. If it says demo or snowflake or anything else weird, you can just change that to data frames, right? And I just want the first 10 rows. So I'm going to say limit 10 and I'll run that. I can either run it by hitting my little play button in the corner of that cell, or you can hit Command Enter on your keyboard. All right. So if all that works, you should get something like this. And you can scroll across and see all the different columns in our athlete data set. All right, you can add more cells below, but what I want you to do just to get the muscle memory going a little bit is first 10 rows of athletes data, first 10 rows of the medalist data set. All right, and then get the number of rows in each of those data sets. I'm going to give you all a minute to do that and to make sure you're all set up. If you're not set up, if you have any questions, you're getting an error message, give me a wave and I will come help. Okay, so you're trying to do two things in the same cell. So I would say just copy paste that second one out to a second cell. Yeah, it's only going to load once. Query in one. Do something once. Get it. Yeah, that should do it. Yeah, good clarification. So you should only have one select statement per SQL cell. So if you write this and then in the same cell you write another select statement, you're going to get an error because it's only going to sort of be able to process one statement at a time. All right, but you can add as many cells as you want, so just feel free to keep on adding them. Okay, did everybody get at least one query to run? Anybody only getting errors? Everybody totally stuck? Okay, great. Cool. How did we get all the rows from our medalists data set? It's my query to get all the rows from my medalists data set. Count, yes, to get my number of rows. Yes, we'll come to that in 1 second. To get my total rows, I'm just going to do exactly the same thing as I did before. Select star from, I can do that from any table. Let's do limit 10 to get an eyeball. Okay, and then second thing, how many rows? That's what you said here. I'm going to select, you said count. Count. I'm going to go in parentheses here, count star from my table, medalist data. All right, so this result, when I run this, is not going to give me a bunch of rows. It's going to give me a single row with this one result. Right, so count stars, just count my rows. Here it says 2,315. That's my single result. And if I go in my data browser on the left, I can cheat a little bit and see how many rows my data set has according to the data browser, and it is in fact the same. All right, it also says 2,315. All right, so I can run count star on any table. I can do the same thing on my athletes table. All right, so select count. My star goes in parentheses here from athletes data. I can do command enter on my keyboard to run. Okay, cool. Any errors, questions about our initial queries? All right, cool.
I have a question.
Yeah.
Could you show how you got on the left-hand side, the list? The database?
Yes, definitely. This is one of the handiest features of Hex. If you hit this little icon, it should just be right below the Hex logo. And then the first time you do that, it'll probably bounce to this screen and you want to hit data frames. Once you're in data frames, you should see it.
Data frames option or just
So you probably didn't run everything first. You want to
Okay.
run all. There you go. Yeah. Make sure you run all when you first open your thing. Oh,
No,
and
I
you're
did,
also in
yeah.
you're in our week 1 data set
Oh
as
my
well.
God.
So yeah, make sure you grab the one that
That's
says
why. That makes sense.
Spring 2025 week 2. That'll work a lot better for you because we were using a different data set last week. So make sure you're looking for spring 2025 week 2 once you're in Hex, also because we had a few folks jump in late. Make sure you go to this link. In there, you'll see a long link to something called Hex. All right, once you're in Hex, you're looking for spring 2025 week 2. And just make sure you do the ... and then duplicate to make your own copy. All right, that'll let you type in your own copy for today. All right, but yeah, everybody make sure you're in week 2 and then you'll have a much better time. Sweet. Okay. Cool. All right, so that's our basic queries. Select everything and select count. All right. Yeah.
Combine the middle list and athletes data into one instruction.
Sorry, could you say that one more time?
Can we combine the medalist and athlete data into one instruction?
Yes, and we are going to be talking about that when we talk about joining in just a second. Yes. Okay. All right. So now that we're a little bit warmed up with SQL, I'm going to talk about kind of the meat of what we're going to get into today, which is data modeling. Okay, what is data modeling? Data modeling is a set of SQL queries that's going to clean up your source data. It's going to make it really easy to ask and answer questions from your data. Okay, so why do we do data modeling? Typically, the source data that you get is going to be kind of disjointed. It's going to make a lot of sense for how the computer stores the information and not quite as much sense for the context of how humans ask questions of information. So our initial data sets, I'm going to use the term source data. Think of these as coming from any system. So say you're working at an internship, the company is going to have a company database. That's a system that information would come from. Maybe you're doing a marketing project and you're also looking at Google Analytics data. That's another system that data could come from. Maybe there's a database that the sales team uses for their opportunities. That's another system, right? So all those different systems create our source data. And typically that data is just a little messy. It's a little hard to ask kind of a standard question, something like, okay, what percent of people at the Olympics won a medal? It's not the most straightforward when all that information is stored in different tables. So some of what we're going to do in our data modeling is do some of the cleanup or combinations or formulas that most people are going to need to answer most kinds of questions to make it a little bit easier. So that's what we're going to talk about today. So I want to talk through an example of what that means. So you can imagine that any school you go to, including this one, has a database, right? And the way that that database is going to store information is going to be like this column on the left, all right? This is a simplified version of how a database might store information about students' grades and enrollment. So the computer is typically going to store this information in 3 different tables. All right, it's going to have some table that's got your student ID number, your first name, your last name, probably a bunch of other stuff, your address, phone number, etc. it's gonna have a table that says which courses you took each semester. So that's gonna have one row per course per student. All right, so let's say all of you are taking, what is it, 4 or 5 classes a semester. There's gonna be 5 rows for each of you in this semester alone. So a bunch more of those over all the semesters over your whole time as a student. Okay, and that's gonna have information like which semester is it? Is it, you know, fall 2025, fall 2024? And the letter grade that you got in that course, A, B, C, D, probably all A's and B's in this room, yes. Okay, and then you're gonna have one other table that's sort of a university registrar database type of table, which is gonna tell us what a letter grade means numerically, all right? There's one central place at the university where somebody's like, all right, A is 94 to 100 and B is, you know, whatever the B is. So that's stored in one place. The university computer is not going to store that same information in every single row of every single enrollment, right? They're going to have one central place where they reference this. And so just your letter grade that you earned is going to be stored here. Something like that, all right? This is a very, very common setup. So if we want to know a very simple question that we might want to know about a student, such as, what is your GPA? Right? Everybody wants to know that when they're a student, right? Or you want to know it for your resume. To get from these 3 tables to your GPA takes a couple of steps. All right, first thing you got to do is look up for each of your letter grades, what's the numerical grade? What's the associated numerical grade? So you're going to make a data model that just does that. You're going to say, all right, I just want all the columns from here and just add a column for numerical grade. Just do that translation for me. Every A is a 95 and every B is an 85 and whatever it is. Give me my numerical grades. All right, so this is something you can do with a SQL query. This we would call a data model, all right? This is another data model because now we got to do the math part of getting to your GPA, all right? This is still going to have one row for each course for each student. So for you this semester, this data model is still going to have like 5 rows if you're taking 5 classes. We want to know what's your average grade so far, all right? And how many courses have you taken? So we essentially want to shrink this table down so it just has one row per student. How many courses did you take and what's your average of your numerical grade, right? Since we can't take averages of a letter mathematically, all right? So you would do a data model here. We would use SQL tools like group by, all right, to group down by student. So this table would have one row per student with how many courses you've taken and what the numerical average of your grades has been so far. And then either in the same data model or possibly in an even separate one called GPA, we would have, and actually we'd probably do it in a separate one for this reason. We'd have your student ID number, we'd have your grade point average, right, which is just your average grade divided by your number of courses. And then we would probably want to add in stuff like your name, right? If you're going to be asking questions of your data set, like which students have the highest GPA, it wouldn't be that helpful if we just had a student ID number and grade point average. We'd want to bring in, say, your first and last name, which we would join in from our overall student database. Okay, so each of these are source tables, these 3 here. These 3 are data models, so a SQL query that we write with the goal of getting to this last one, which is just the thing we want to answer our question. All right, if anytime somebody wanted to know their GPA, they had to join together 3 tables, that would not be useful. All right, but if we have a quick way to get to everybody's GPA, that's a commonly asked business question or context question. We have done this part already, and somebody else could just come in and look in this one spot for their GPA. Okay, does that kind of idea make sense of what we're doing? Or we're getting from here over to the yellow? Any questions about this? Okay, cool. So this is sort of a simple example with students. We're going to actually walk through some examples of this with our Olympics data, right? Before we get to that, just another kind of like, why are we doing data modeling? I've worked in data jobs for a long time. A big part of working in a data related job is you get requests from people. Can you just quickly, how much did we spend on marketing last month? And what's the ROI of this? And normally when people are asking questions like that, they think that the data is just somewhere that I just produced from a magic box. Okay, and that's not the case. say someone asking for their GPA before we've done any data modeling, I would actually have to do like 3 steps to even tell them their GPA. All right, so this idea that there's just some very clean data table that already exists is kind of a joke in the data world, because that table doesn't always exist the way that the maybe business side of the business thinks it does. But once you've done a little bit of data modeling, you just go, boom, go straight to my student GPA table that I made last year when somebody asked me this question, and I don't have to redo all those steps, all right? Okay. So one of the key components that I just talked about in this model was joining, right? Joining meaning we started with 3 source tables over here and we got down to 1 table. So we did some joining of our 3 tables to get down to 1. There are several types of joins in SQL. For the purposes of simplification, I'm going to talk about only 2. And primarily, you're likely primarily going to be using this second one, all right? But just to explain the difference between these 2, when you're joining 2 tables of data together, you got to make some choices about what to do with any rows that don't exist in both tables. All right, like let's say I'm a student who just enrolled, but I haven't taken any classes yet. All right, so I'm signed up, I'm coming to USC, but I'm not actually enrolled in a specific course yet. So I would exist in that student table from the previous slide, right? My name, Rachel, student 102, would be there, but I wouldn't exist in the enrollment table because I hadn't actually enrolled in an individual class. There'd be no rows for my student ID number in that table. So I have 2 choices. Either I can join and say, I'm actually only looking for students that exist in both tables, meaning I'm going to drop the people who aren't yet in the second table. That's a regular join. All right, so if it's just the word join, no other words, that's a regular join. The other option, the one I find I use most frequently, is a left join, meaning I'm going to pick one of my tables metaphorically set on the left or first. I'm going to take all the rows from that one. And then if my second table has any that match, I'll add those on. But I'll keep everything in my first table, even if it's not in the second one. All right. So I would keep myself, even if I wasn't enrolled in any classes, I would keep the row that says Rachel as a student. All right. Even though I don't have anything to join on for my enrollment. So those are sort of the 2 ways to think about joining. Typically in the real world, you're mostly going to use a left. There are a few others, but we're going to start with these 2 for today. Okay. All right. This is a lot of words. This is mostly for when you look at the deck after class, but this is just a way to kind of think about how do you go from sort of the question that you're asking in your head to how do you build the query in SQL. Okay, so this is sort of me trying to write out how you would think about going from your question to your query. We talked about this a little bit last time. So the first question you ask is the same question you ask anytime you're writing a query, right? What tables have the columns that I want? So what's my end result? My end result I want is student ID number, first name, last name, GPA. That's the end result that I want. So what tables have that information? Probably my student table, this grades table, this enrollments table. When I look at those tables, do they have 1 row per entity? Meaning in my result, I want 1 row per student. So which of my tables already have 1 row per student? And which of my tables might have more than 1 row per student? Okay, so my student table already has 1 row per student, self-explanatory. My enrollments table, as we just talked about, is going to have a bunch of rows for an individual student because it's going to have 1 row for every time you, the student, took a class. All right, so anytime your table is going to have more than 1 row per entity, you're going to need to summarize or do a group by of some kind to get it down to the same number of rows so you can join. All right, so I might do something like select student, count star from enrollment to get the just number of classes you've taken. Okay. And then that group by will bring me down to just a single row per student. This is where you're going to pick your type of join. Do you want only the rows that appear in both tables, or do you want all the rows that are in this table and then sort of augment with anything in the second table? That's where you pick join or left join. All right. Using we touched on this last week and in the little review. So this is where you're gonna tell the join which column is the same. In my previous example, it'd be student ID number. So I would say using student ID number. A little trick is if you've given that column the same name, if that column has the same title in both tables, you can just say using. If they're named slightly differently, you can do on whatever it's named in the first table equals whatever it's named in the second table. Okay, so if it's student ID and student ID number in the second one, you can just sort of tell it how to map that across. Okay, and the very last thing is just what columns do you want to end up with? Okay, so same as a regular query, you can name the specific columns that you want. You can do a formula like count or average or other math to get your result. All right, so these are just kind of like the kinds of questions, the kind of thoughts you should be having to yourself for the rest of this class as we work through a bunch of exercises. Okay? Any questions about this?
The second step, is group by one a command or is it like a name?
Yeah, group by one. So group by is a clause that you might use in your query. And then to tell it what to group by, you can either tell it the name of the column or you can tell them which column it is, like 1, 2, or 3. It accomplishes the same thing. So I could have said group by sport here since sport is my column, and that would do exactly the same thing. Just a preference. All right. Okay. Just a little bit of a review of what you can use for where conditions. All right, so this is just like reminding yourself on some like math formula typing if you haven't done that in a minute. Anything you're going to say in your where, so say I want countries where there were more than 10 medals won in the Olympics, for example, then I would do greater than 10. All right, so I can use all of these anywhere I want in my where. So I can say is something equal to something, exclamation point equals is the not equals. All right, less than, greater than, less than or equal to, greater than or equal to, those are all valid for your where. The other situation you might be using the where clause for to kind of filter down is for text or strings, as it's often called in the data space. Same thing here. So as long as you've got it in your single quotes, you could say, is this string equal to this string? So I want all the medals where type equals bold. Okay, that's like a where clause you could use. Same thing, not equal. You can give it a list of text. So is it in this list of things? All right, you can give it a list of things in single quotes. And I can also do, is it like this text? Meaning, does it contain text that matches this? Or I can do I like, which is, I don't know if it's capitalized or not. I is for case insensitive. And this will let me check if that phrase exists in my overall text. We'll come back to this. This is just to give you an idea of the kinds of things you can do with your where clause. All right. That was a bunch of me talking. We're going to get into a little bit more practice. All right. So if you're in your copy of our exercise today, you scroll down past our first exercise and get down to our second one. So this is the question that we are trying to answer. What percentage of rowers who competed at the Olympics received a medal? All right. So the thought process you should be going through is, based on your tables that we have, what tables do you think we need? What columns are you going to want in your result? And what columns do you think you might need to join? So as a hint, we have our athletes and we have our medalists table. Those are the two we've been looking at so far. Consider that a strong hint of what tables we might need. All right. And you want to start thinking about what pieces of information. So what is a percentage? A percentage is a fraction of the whole. So we need to know how many rowers competed in total at the Olympics. We need to know how many of rowers received a medal at the Olympics. And then we need to put those two pieces of information in the same place so that we can divide one by the other, right? If we find that there's 100 rowers and 10 of them won a medal, that's 10%, right? That's the answer that we're trying to get to. So you should start by writing the simplest SQL query you can think of that's like vaguely related to this. So maybe a good place to start would be, how many rowers are there? Or how many medalists are rowers? Be a good place to start. I'm gonna give everyone a minute to think about that, maybe start trying a few things. If you're feeling stuck, you should go back up to the place where we did our select star data and just kind of scroll across, start looking at what columns might be relevant for this, what you might want to filter by. All right, and same thing for our athletes data. So if you're feeling stuck, go back and look. Start thinking about what's the first piece of information you could get that would get you closer to this question. So I'm gonna give everybody a couple minutes to think about that, then we'll come back. And I'll come and answer questions. Yeah, it's this one right here. Yep, you just log in through USC. Okay, take me to my workspace. It's just saying you've already joined. Yep, and then just make sure you make a copy for the two. Spring 2025, that's everyone. Spring 2025. Yep. Perfect, yeah, no problem. So. Okay, it looks like this one is grabbing from it. Yeah, so hit this. And then change it to data frames. Yeah, and then that should work. So try. Yeah, it might just be a typo. Maybe just make sure that you're just missing an S there, maybe. And then on this, yeah, you're gonna use sources into data. Yeah, you got it. Yes. Great.
What column should you use in short?
Right, so that there's 2,315 rows.
Oh,
here.
right.
So you might want to select our or distinct disciplines. Do you remember how to do that from last week? Okay. Yeah. After select, do distinct or distinct space. Yep. Oh, there you go. Nice. Okay. All right, okay. Seeing a few people get started, so let's kind of talk through what I'm seeing so far. So first thing you want to get for a percentage is what's my total number, right? How many total people am I talking about? So I want to get all of my people who are rowers. All right, so how would I do that? Probably I would start with going back up and looking at my athletes data table. And I'm going to try to figure out which of these columns is going to tell me that this person is a rower. So far, I just know that all these people are from Armenia. All right, keep going. We got height, weight, discipline, event. Oh, I'm back to disciplines. Okay, discipline wrestling. That looks like a column that might tell me if this person is a rower. All right. So one way I might check that hypothesis without having to scroll through all 10,000 rows of my athletes is I might go and select what are all the possible disciplines. All right, so I'm gonna figure out, select discipline from my athletes data, and let's see if I can find rowing. Is it just called rowing? Is it called something similar? Let's go check. All right, oh, I didn't spell discipline correctly. Let me go copy paste it. Oh, disciplines with an S, okay. Coming back down, so I got this error, right? Reference column discipline not found. If it's a column not found, it's usually a typo. All right, so I'll just go and double check my column name, which I can do either in my data browser or by scrolling back up to where I queried this before. But I'll see that it's disciplines with an S. So I add that, give that a whirl. Okay, great. Now I'm seeing wrestling, swimming. All right, boxing, cool. Oh, I see a couple rowing. Great. All right. So it looks like this rowing thing is spelled like this. So it's got this like bracket quote, end bracket or end quote, end bracket thing going on. But I know that that is rowing. So if I want the number of athletes that are rowers, I'm going to want to filter by this text. All right, so I want to do something like add a where. And I'm going to do disciplines because that's the column that I'm looking at. And then I'm going to need to choose my where clause. All right, now it looks like there's maybe a bunch of possible ways these are spelled. So if I browse through, looks like there's a bunch of these. I'm wondering if any of the athletes maybe compete in multiple sports. Not sure. So when I'm picking my where clause to go back here, I'm going to say I want to grab the phrase rowing. I want to say just if the phrase rowing exists in your disciplines, I'm going to call that good enough because this data set seems really big. If I do an exactly equals, I might miss somebody if there's like an extra space or something. So I'm just going to do if it's like the phrase rowing, we're going to count it. All right, so I'm going to come back over to my query and I'm going to use I like. All right. And I'm going to do rowing. Now, the way that I tell it that rowing might be somewhere in the middle of my string is I'm going to add these percentage signs. All right, that's my little trick. It's kind of like a wild card in like a Boolean search. All right, so this is going to say if anywhere in the other string says rowing, we're going to count it as a match. All right, as long as it says rowing in there somewhere. All right, so let's give that a whirl. All right, cool. And that's getting me rowing in everybody's row, pun not intended. Okay. And I don't really want just in this big line though, I just want the number. I want to know how many of these people there are. All right, so I would edit this to just be my count, just like we did before. Count star from my athletes data, where the discipline, I like rowing. All right, now because it's a string, I've got this in single quotes. And because I'm using this I like or case insensitive, like similar to text, I've added those percentage signs just to say, I don't know what would come before or after rowing, but let's go with this. Okay. Let me run that and then I'll see it condenses down to 493. All right, so that's got me sort of like third of the way there, right? I need to know what percent of, oh, did I skip ahead by one? Oh, maybe I skipped to rowing. Well, maybe this would be simpler. Looking at the same version of this here. Yeah, percentage of hours. Okay, sorry, my notes. Something else. Oh, because I came down to task 3, that's why. Okay, all good. All right. Still in task 2. Okay, great. Okay, so I have my number of athletes that at the Olympics that are rowers, 493. Just to gut check that number, that makes sense because there's a bunch of people in those boats. There's a bunch of countries. That number kind of just makes sense. Okay, great. Next thing I should figure out is how many of these people earned a medal. All right, so next thing I would want to do is look at my medalist data. Okay, this I grabbed from my athletes data table and my medal data is in my medalist data table. Now, presumably everyone in the medalist table is also in the athletes table, meaning in order to win a medal at the Olympics, you have to be at the Olympics, right? But not everyone in the athletes table is in the medalist table, meaning not everyone who goes to the Olympics comes home with a medal, because that would not be fun to watch on television, okay? So I need to join these two pieces of information together. All right, so to do that, I'm gonna go look at my medalist data. All right, so here's my medalists, and I'm gonna come look at all of these. So I've got a name, I've got a medal code. All right, I've got all kinds of stuff in here. And I've got this code athlete, which is kind of a weird looking number. All right, cool. And all these people are medalists. All right, so I want to think about how I could join this data together with my athletes data up here, meaning what's a column that exists, column or columns that exist in both of these tables that could combine them together, right? That would give me sort of the mapping of this person is the same as this person. Now in my athletes data, I'm seeing this first column here, which is code, which looks like it's a 7-digit number. And then down here in my medalist data, I've scrolled across and I'm seeing this column called code athlete, which also looks like a 7-digit number. All right, so based on looking at this with my eyeballs, I'm gonna say that looks like some sort of athlete ID number. That looks like that would be an easy way to figure out who's the same person. Now there's also a name column, but name columns, their name could be typed in differently in the results versus their initial registration, et cetera. So safer to use something like an ID. All right, so I've got my medalist data. I've got this column code athlete here. In my other table, it's just called code. So now I want to join it in. Right? If you have a join, it's always going to happen right after your from. Okay, it needs to be before anything else, after your from, but before anything else. So in this case, I'm going to join. Now I'm going to do a left join here and not a regular join. Because if I do a regular join, I'm only going to get those two people and the people who are in both tables, meaning I'm going to drop anyone who didn't win a medal. And that's going to make it impossible for me to find the percentage of all athletes who won a medal, right? I don't want to drop those people. Because I don't want to drop them, I'm going to choose a left join, meaning my athletes table is on the left, keep all those people. Anybody who won a medal, add some info about their medal on, right? All right, so I'm doing my left join. I'm going to say left join medalists data. All right, that's the name of my other data frame, medalists data. All right, and then I got to tell it how to join. Now, because in one table and here the column is called code, here it's called athlete code, I'm going to say on. And then I'm going to tell it what those two column names are with an equal sign between. All right, so I'm going to say on code equals athlete. Spelled that correctly. And that's going to join that information on. All right. Let's give that a run. All right. We got an error. Athlete code. It's not found in the from. Cool. Oh, because it's code athlete, not athlete code. All right. Sweet. Some of you already caught that that was a typo. Thank you. All right, code equals code athlete underscore. Okay, let's try that.
Okay.
Beautiful. Okay, that's all of it. So just a reminder, if you get an error message, read the first sentence of the error message. It's often helpful. Okay, so this is cool. I'm getting my same result that I got before I added this whole left join. All right, I could comment this out, meaning actually temporarily remove it, run it, and I get the same result. All right. Which is super cool. Okay, so I'm joining on my code, my athlete code, right? Because this is my column that's the same in both of my tables, right? It's got my same result. Okay, next thing that we're gonna do is add some information from our medalist table. All right, so right now I'm still just getting my total count, but the reason that I joined this table in is that I want to know how many of those are medalists. So I'm going to go back up to my medalist table and think to myself, is there a column that would be an easy way to summarize just, yes, all of these people are medalists. So I'm going to go back and just kind of scroll across. look at all my column options. This last one is just called is medalist. Looks like it's true for everybody. That makes sense because we are in the medalist table. Okay, so I'm going to come down and do a count. So I've got my count star already. I'll rename that as something like number rowers. Okay. Rename any column with as, especially if you're going to do a count, it's a good idea to rename it so that it doesn't show up with like this weird thing in your results. And then I'm going to do another count, but I'm going to do a count specifically in a certain case. Okay, so I'm going to use my case statement, which is case when some condition, then count something, end. All right. Just kind of the format of my case. So when is medalist was a true false. So I can just type the column name is medalist. So when is medalist, meaning when that column is true, then what do I count? I'll just keep it easy and I'll just count the number of athlete codes, meaning just count every row where that is a medalist that has an athlete code, which should be all of them. I got to include this word end when I'm done telling it my when then. And I'll rename this too. I'll give this a name like medalist rowers, something like that. Okay, so I'll give it a column name and see if that runs. Okay, cool. So now I'm getting here the same initial number that I got, right? My original count, I've just retitled my column. And now I've added a second column, which comes from my count case statement. All right, so this number should be smaller than this number, right? Because my case is essentially an additional filter. And it looks like it is, right? It looks like 144 out of 500-ish rowers are in the medalist table, which is pretty cool.
I have a question.
Yeah.
You left join the medalist data to the athletes data. So the rowers who don't have a medal have the column is medalist, but no data in that. Like
Correct. Yes, exactly. Yep. So no data reads the same as false in like a true false situation. Yep. Good question. Okay. So we have our total number of rowers. We have the number of rowers who earned a medal. Math pop quiz. How do I get from these two numbers to a percentage? Divide? Yes, I divide them. Very good. Not intended to be a trick question. Okay, so I'm going to add a comma. So I'll get one more column in my results. And in that column, I'm going to do some math with my other two columns. So all I'm going to do is divide this guy by this guy, right? 144 out of 497 earned a medal. So whatever that division is my percentage. All right, so I'm going to say divide medalist rowers by number of rowers. All right. We'll call that as percent medalists. I don't know. I spelled everything correctly. Boom. Okay, added my third column, 28%. I can gut check 150 out of 500-ish. That sounds about right. 28% of rowers at the Olympics came home with a medal. Pretty cool. Question?
What's the functions of code in the second?
Second.
The functions of code.
Yes. Okay. So this is just giving it something to count. You want to give it a column that's just filled in for everybody. So it's essentially any row where is medalist is true. What should you go through and count? A case where you might use, so we're just looking for a row with everything filled in because we wanted to count everybody. You might, in a different situation, choose to use a row that like wouldn't be filled in for everybody. For example, let's say if this condition is true, then this may or may not be blank and you just want to count how many times it's not blank. So essentially the then is just counting everything that's not blank. So you just want to give it something that's filled in for everybody. Yeah.
Can we just simply use count is medalist? In the second one?
Yes, we totally could do that. So another way to write this would be get rid of this guy, get rid of our case, and count whether it's medalist. Yes, that would also work. Yeah, so what it's doing to simplify this, we removed our case statement. Because is medalist is a true false column, it counts each true as 1 and each false as 0. So to count a column like this, it's like 1s for true, 0s for false. The reason to use a case would be if it's anything other than a true false column, you would need to use a case statement there. But yeah, because this one's true false, this also totally works. Good question.
Mine didn't came out as percentage because I did not multiply 100, like,
Okay, cool. This is a handy hex thing. So you could either multiply by 100 in your SQL, so you could add a, star 100 here, or you can come down and click on this column in hex and format it as a percent. So it'll do that part for you. I think because I had the word percent in my column name, it like auto did that. But you can come in as format, hit percent. You could do the same thing for currency if you're doing like anything involving dollar amounts. Just kind of a handy dandy thing. Yeah. Question. Yeah.
We do use case.
Mhm.
Is it because like you said, left join more equals code athlete? It doesn't really matter whether you say it's code athlete, even though it's not named as code in.
Oh, good question. Yeah, it should work either way because we're assuming that everybody in the medalist table is in the athlete table. So it should work either way. Yeah. Yeah, we also could have used the name. We could have used something else. Yeah. Okay, good questions. Cool. Anybody get any errors on theirs? Anybody stuck on theirs? Okay. Cool. All right. Any questions about this? Okay, great. So what we're gonna do next is a bunch more practice, all right? Because the only way to kind of get a handle on these things, I can't just sort of like speak SQL queries at you. The best way to learn them is to try writing them. So we're gonna do a bunch more examples of what we just did, all right? So our next one, if you scroll down, is gonna be our task 3, all right? So I'm gonna give you some time to try this. So for each sport discipline, what percentage of athletes earned medals? And then from that, which sport has the lowest percentage of medal winners? All right, if you go to the Olympics as a rower, you have almost a third of a chance of coming home with a medal. All right, what sport has the lowest percent? All right, so as a little hint, you're gonna need to group by disciplines. All right, you can kind of figure that out from the question for each sport discipline. All right, SQL is very kind of maps pretty easily like that, right? So I'm going to give you all a minute to think about this. As a hint, you might want to do something sort of similar to what we did for task 2, but not filtered by a specific sport and instead grouping by a discipline or sport. Okay. So use what we just did. Want percentage earned medals in each sport discipline. And then once you've got that, we just want to find out what sport has the lowest percent. Okay. To give you all maybe 4 or 5 minutes to take a stab at that.
Bây giờ phải đặt cái này phải đặt specific discipline. Nhưng mà nó thì cái tên này
Just put the from and left choice and then select count.
So your select always has to go before your from. All right, so it's got to go select, then from, then anything else. So let's see. Yeah, so this whole select part has just got to go before your from. So you just got to copy paste it up above. It's just a syntax thing. It's just got to go in that order. Yeah.
Đúng rồi, em select bao nhiêu cái thì sẽ chạy ra.
All right, has anybody got our percent by sport?
Discipline là cái cột. Đúng rồi, cái tên của cái cột.
All right. Anyone have percent by discipline figured out? Maybe just a little nod, so I have a sense where people are at.
Thêm một này chứ không phải là thêm một này. Xong rồi
Okay,
join.
all right. So let's talk about it. Okay, so this is pretty similar to our last question. So what I'm gonna do is take this query that we wrote for the last one. I'm gonna copy paste it and start from there. Okay, so things I wanna remove are the where disciplines equals rowing or is like rowing, because I don't want just rowing for this question. I want all the disciplines. So I'm gonna delete that out. All right, and I'm just gonna see if this runs with that deleted. Okay, so I'm just gonna run my query. Okay. I would recommend doing that anytime you edit, anytime you add a short bit or remove a short bit to your query, just run it, see if it works. And then add or remove your next bit, run it again. Okay, you should be running it a bunch of times as you're writing it. That way you know where you're might be on or off track. Okay, now this is pretty interesting. I've got number of rowers is a bunch of stuff. Medalists is a little bit fewer than that, percent, 20%. Okay, so I'm not filtering down anymore. My column names are a little misleading because I'm not just rowers anymore. So maybe I'll change these to athletes instead of rowers. Just for my own brain here. All right, all I'm changing there is the labels. All right, oh boy. Oh, but I didn't change them here. Change the spot as well, athletes. All right, athletes. Just changing my labels to not be rowing specific anymore. Otherwise, left this completely the same. Okay, so this is great. So I have my total athletes who attended the Olympics, total number who won a medal, and my percent of medalists. So all I did was I took the last query we wrote and I removed the rowing, the where clause about rowing. Okay, so already I can tell I'm a good chunk of the way there, right? I want to know what percentage of athletes earn medals. I've got that. The only piece I'm missing is by discipline. Okay, so I have this for all athletes. I'm just not grouping by anything. All right, so what I would want to do from here is just add my group by, right? All I want to do from here is group by my discipline. All right, so again, your group bys are always going to come after any joins you have, any wheres, or after your joins, after any wheres. So I'm going to add my group by, and I'm going to say group by disciplines. All right, let's give that a whirl, but I think that's going to give me, cool, this is fun. This is helpful, but it's going to be missing one thing, which is I forgot to add a column that's going to tell me which discipline is which. So for this one, there were 291 athletes, 72 won a medal, so it's 24% medalists. But I forgot to include my column that tells me which discipline that is, which isn't super helpful. So I would probably just want to come back up here and add disciplines. Remember, I'm going to separate my columns with a comma always, otherwise I'll get an error. All right, so disciplines, comma. All right, and let's try that again. Cool. All right, so same thing here. My 291, my 72, that's the same. Now it's just actually telling me that that's wrestling, which is pretty useful. Okay, cool. Any questions about how we got from our previous query to this query? Yes, question.
I tried adding disciplines column, like right after count as number of athletes, and it didn't work. Does the like the order which the columns are added matter?
That's a great question. Conventionally, you would do anything where you're doing count would always be to the right of anything you're grouping by. Actually not 100% sure if that just always fails. That should work. You might have been missing a comma or something when you moved
Okay.
it. This does work, but typically it's more common to see whatever it's grouping by as kind of the leftmost column, and then any like summer, like counts, averages, sums, anything like that, more to the right. Yeah. Down here?
Yeah, like, why are they grouped together? Like, why are two?
Yes, okay, good question. It looks like what's happening here, and also from just eyeballing cycling road, cycling track, cycling road, cycling mountain, and then there's only two, these are smaller numbers. I think what that means is that two athletes competed in both of these sport disciplines at the Olympics. So the disciplines for that person are these two. And so of the two people who competed in both of these events, one of them got a medal. Yeah, good question. Yeah.
Can you explain again, what you added to add the disciplines column?
Yes, okay, great. So before I added the disciplines column, I'm gonna comment this out. So anytime there's a double dash, that's a comment. That just means it won't run anything after that. So I frequently use that as I'm just trying things. That's what I'm gonna do here. All right, so before I added my disciplines column, all right, all I had was this. So I'm just selecting my total count and my total medalist count from these two tables, and then I'm doing the division. All right, so I'm not, this is because I've got my two dashes here, this isn't running, right? So this is exactly the same as what we had here. I just removed my where disciplines is rowing. All right, so to add my grouping by disciplines, I did two things. First thing I did was I added this group by disciplines. All right, so it's always going to come after your join, just give it whatever column name. It can group by a column name that you haven't told it about. All right, so I can say this, and it found disciplines in my athletes data table, so it went ahead and grouped them, but it did not tell me actually what it was. So the last thing I did is I just said in the list of columns that you give in my results, which is the stuff in your select, just include disciplines there. That should do it. Question. Did that answer your question?
But I got there.
Okay, cool. Yeah.
I'm gonna ask, like, since the question asks for each sport discipline, like, if we're getting two disciplines grouped together, like, could we do something to clean that up?
Yes, we are going to talk about cleaning up a similar thing in a second. Good question. What error are you getting now?
Binder error, column discipline must appear in 45.
Must appear in the group by clause. Okay, so do you have a group by?
Oh, I forgot.
There you
There you
go.
go.
That'll do it. The errors look a little scary, but can actually be quite helpful. Okay, any other questions about grouping our medalists by disciplines? And I guess our very last thing would be, we wanted to know what sport has our lowest percentage of medal winners. So to do that, we would just add one more line to our thing here, which is on order by. And I don't want to order by discipline. I don't want to order by number of athletes. I don't want to order by medalist athletes. I want to order by percent. 5% medalists. And let's see, I actually don't remember what sport this is. Let's check. Cycling, man, you have less than 5% chance of coming home with a medal if you go for road cycling. That is rough. I would recommend going for rowing if you really want a medal. That's low. Okay, so this is my exact same query. All I did is I added this last line, okay, order by, and then I gave it the column name I wanted to order by, which is my percent medalist. Okay, as a default, it always orders from low to high, but in this case, I actually want it to do that, so it's all good. If I'd wanted it to order high to low, say what sport am I most likely to come home with the medal, I would keep this all the same and add DESC for descending. It's even like handy in the auto complete. It'll remind me that that's what it is. And let's try that. Okay, now this is where our data is a little less clean. We've got a few of these that are very small groups because they're people doing multiple sports, but looks like one of the first big sports is cycling track. All right, so you're much more likely to come home with a medal in 3x3 basketball or cycling track. So if you're a cyclist, you should do the track thing. I think it's what we're learning if you want an Olympic medal. Cool. All right, any errors, any questions about how we got to this? Yeah.
So when I do that, I get my two first rows are athletics and equestrian, not cycling row.
Do you have them, do you have it on, I just took my descending off.
Yeah.
Athletics, equestrian here.
Yeah, but we.
Oh,
But the percent
Yeah.
for percent
you-
medalist for
Are
those two.
you, did you order by disciplines or did you order by percent?
I order by percent medalist.
All right, let's come.
I've got the same response.
You got the same result as him? You know what it might be?
Like, I think it's because of like, for like in line 3, we did count as medalists, and that's actually different from like when we're doing case.
Okay, interesting. Interesting. All right, so the people who have the case win are getting a slightly different. This might be a data cleanliness problem because our case is counting code, assuming that the code row is not blank for anybody, but it might be blank for a few people. So that could be the case. Let's try that. And code. Okay, yeah. So I think what that probably means is that a few of these weirder ones, so if I take this back out. Yeah, a few of these like weirder rows might not be counting our case, or its medalist column could be a little messy. Yeah, a couple possible data cleanliness situations. Yeah.
Would the order matter?
Oh.
Let's say I wanna move the group by order by to the top, would that mess up the code?
Would that mess up the code? Let's test it. Group by, order by to the top. It would mess with it, yes. Yeah, your select always has to come first, and that's why I gave you your little kind of cheat sheet up here in the top of this document, this thing. So this, you don't have to have all these things, but if you do have them, they have to go in this order. So anytime you're adding an order by, it has to go after a group by. If you're adding a where, it has to go after your from, after your join. Yeah, so if you have the stuff, it has to go in that order, but it's not all required. Good question. All right. Any other questions, errors? So yeah, if I were a data analyst and I was actually like working on this as a project, I would go look at my source data to figure out why count is medalist is slightly different from count case when is medalist, then code. Probably a couple of those rows, there's probably something a little funky in my source data. I would go investigate that more. Make sure there weren't any blank rows, any like data quality issues in my source data. Cool. Any more questions on this one? Okay, we are gonna keep rolling along on these. This is our next one. And this is gonna be a little bit of cleanup, as somebody asked about a moment ago, okay? So we will notice, as we've already talked about a little bit, that our data quality is not perfect in our disciplines thing. For example, there are a few folks for whom they have equestrian written like this, bracket, equestrian, bracket, instead of how they have it written for everybody else, which is bracket, quote, equestrian, quote, bracket. All right. So that is what we were actually seeing up here, right? You can see there's 246 folks who are in the discipline equestrian as it's spelled here. But actually, as we had our query earlier, we had equestrian at the top. We see there's one athlete where it's spelled slightly differently. They just didn't include the quotes. That's a data quality problem. We've identified that. That is a problem that we can clean up using SQL. Okay, so we are going to do that in this task using a case statement. Okay, so what we're going to do is we want to essentially just have all of our data from this result that we got. So it's saved to data frame 4. Okay, so I can query this data frame directly with this is its name. My result here is named this. I could name it something more useful just by double clicking on it. I might call it medals by disciplines. Got to be something with no spaces. So I'm going to use some underscores. Hit enter. Okay, this is medals by discipline. This result from my last thing. So now down here, I can select from this just like it's a table. So I can say select star from medal, that name I just gave it, medals by discipline, and you'll see it even pops up in my autocomplete. All right, so all I did was in the little green where it gave me a data frame name, I gave it a new name, and now I can select from it. Pretty cool. Now it's just treating this as my source data. All right, so I wanted to do a little bit of manipulation here to replace this equestrian that's spelled a little differently to make it so that it's counted in, right? Because there should be 247 equestrian athletes, right? There's these 246 plus this one, right? It should really be 247. So how do I get those into my same row? Essentially what I want to do is say, when you find equestrian spelled like this, actually spell it like this. Okay, that's what I would like to tell my query to do. Okay, so you're going to use a case statement for that. What you're trying to do is whenever you find the discipline is this, make the discipline this. Okay, that's what we want to do. I'm going to give you all a minute to try that. There's a second hint there about your string. That it'll need to be, any string is going to need to be in single quotes. All right, if you're finding yourself needing to put a whole string in quotes, but that string itself contains quotes, you can sort of escape it, as it's called, or get around that problem by adding an extra single quote in front of your single quote. If you're confused by that, ignore that, start with the case piece. So we want our medals by discipline table. We want sort of that same table, but we want our 247 equestrians together instead of that one being separate. We want to fix that spelling using our case statement. Okay, so I'm going to give you all a couple minutes to think about that. Get an error, if you're stuck, give me a wave. I'll come. Okay.
Can you scroll back up to what you had for the task number 3? Thank you.
I'm just going to hide the results so you can see it at the same time. All right, okay, let's talk about how this case statement works. All right, so I'll lay out my case statement. All right, so essentially what I'm doing here is I'm making a correction in my disciplines column. Okay, so I just want to say when a certain condition applies to my disciplines column, make this little fix, make this little tweak, the specific spelling update. Otherwise, just grab the regular discipline as it is. Not all of them need to be fixed, just this one or two. Okay, and then treat that like I would treat as if that were my disciplines column. All right, because right now, I've got these two little bits of messy data. Okay, I've got equestrian, I've got athletics, which is like this. Okay. And it's gonna look a lot neater if I can clean that up and I can just sort of pretend this problem didn't happen as if these had always been the same, spelled the same. All right, so what I wanna fix is when, so exactly the same logic as the question is phrased. When it's spelled that way, then spell it that way. That's the fix I'm telling it to do. If I were gonna go fix it in a spreadsheet, that's what I do manually, so that's what I'm gonna tell it here. So when disciplines is this string right here, I'm just gonna copy paste this, I don't have to type it. It's a string, so I'm gonna put it in single quotes. Okay, so when disciplines is spelled like that, then spell it the way it's spelled for most people, which I can scroll down and see is right here. All right, so for most people, it's spelled like this with my quotes. All right, so when disciplines is that, that's my condition. Then grab this string instead. Okay, so I'm gonna do my quotes and I'm just gonna paste in this guy because that's how it's spelled for most people. All right, cool. Ooh, but I get a quick visual clue that something is weird, right? Because this string highlighted in red, we've seen it's done some like color highlighting for us as we type, right? This string got weird. It's red and then white in the middle and then red again. All right, so something's looking a little strange. This is where my second hint comes into effect. So this string of text itself contains the single quote, which is the same as the single quote is the tool you use SQL to tell it that it's a string of text instead of like a number. So it thinks that you have a little string that is this just this bracket, then some random typing that's possibly a number, and then this other string. Obviously, that's not what I meant, right? I mean the whole thing is a string. So to correct that, I come and put an extra single quote inside my string right here and inside my string right here. So I'm putting an extra single quote before these guys. So that double single quote character is just telling it, this is just a single quote part of the string. Don't stop the string. Let this whole chunk of text be my string. It's just a little signal for the specific case where your quote contains a single string, but you need it to, or a single quote, but the single quotes are what you need to delineate it, okay? So that's what that second hint is. All right, we're just simply putting a little extra single quote in there to read it as a string properly. Okay, and then the last bit of my case statement, which we didn't use in our previous case statement because we didn't need it, but we do here, is else. So if the discipline is this one thing, then spell it this way. If the discipline is not that thing in any other situation, just use it how it's spelled. So just grab whatever's in that column, meaning just grab the value in the column disciplines. All right. That will get us where we need to go. Case statements work the same way as other queries, meaning I could put this stuff on a separate line if I want, if that makes it easier for you to read. Up to you, this will still run the same way. All right, I can run this. Cool, and I can see it separated out equestrian. Now it would be handy if, so my results up here, right, I had this one athlete and then my 200 and something down here, 246. I actually want those numbers to be all added up, right? I want this to be treated as though it was one of all of those. So I'm actually just going to come grab my same query that I wrote before. I'm actually just going to come copy paste all this. And instead of in this query where I just said the disciplines column, I'm going to say, use this new disciplines column that I wrote. All right. So I'm just pasting in everything from, say, an extra comma. So this whole part is just copy pasted from the previous thing we wrote, which just had our column disciplines. I've just essentially replaced that first column with my new case statement, which is just making this correction. All right, so when I run that, you'll see my result looks very similar to how it did before. But now I've got my same columns. I've got my same percentages. I could make the same correction if I wanted to for, we see athletics also has this like weird spelling issue. All right, so I could do the same in your case statement. You can add multiple when then pairs, meaning I can copy paste this part, add my whole thing in again. So I have case when then, and then another when then before my else. All right, so I could replace this with this weird athletics one. This weird athletics one. I don't actually know what sport that is in the Olympics. And I want to group this by, I should have named this something else. I actually name this discipline clean, call it something like that. Then make sure I'm grouping it by my new cleaned up column instead of the old one. Fantastic. Okay, so now, so I just changed this because I changed the name of what I'm grouping this column as, so I'm not reusing the name. Okay, so all this is saying is when you find this weird spelling of equestrian, do the right spelling, do the same thing for athletics. Otherwise, just grab whatever it said before. Everybody else seems to be spelled correctly. And you'll notice, and then this whole other part is just copy pasted from above. My query above had 52 rows, as it's going to tell me in the little summary. And this guy has 50, meaning I got rid of those 2 rows of my sort of like weird unclean data. and they're now combined. So if I go find equestrian in this list, now it has my 247. So it added my one guy back in. So to answer your question about how we did a little bit of like data cleanup, this is like one way you can do some data cleanup in SQL. But commonly you would use case statements for that situation. Okay, yeah, question.
Mine is error.
Okay, what's your error say?
Syntax error at or near the bracket.
At or near the bracket. Okay, that might mean you didn't get your second quote in. So your whole string here should be highlighted in red. And you should have single quote, bracket, single quote, equestrian, single quote, bracket, single quote. That's what you got? You might be missing a comma after. The other thing to look for with a syntax error is usually a missing comma. Let's take a look. Yeah, it looks like your athletics one, you've got an extra one. See how the brackets shine up in black instead of red, you got a third one. Yep, try that.
Then this.
Great. Okay, so then all I did after that, so that's what I did initially as well. I just copy pasted this part from our previous query.
Oh.
So instead of just doing disciplines the column, I essentially just copy pasted this guy down here. And then the last piece I did is I changed this name. So instead of having the same name disciplines, I changed it to discipline clean to make sure that when I group it, it's grouping by my new clean version. So it's adding those two equestrian groups together. Cool. Other questions? All right. We have more like possible tasks in this sheet than we will get done today. So if you're feeling great about this, you're feeling on top of it, feel free to move ahead of us. There's plenty of stuff for you to do, but we will keep on rolling along. Okay. So this is just a little bit of a review of some SQL functions. Okay, just some of the same notes I had in our slide, but just a quick refresher. All right, so our case statement is going to be used when we want to select just some rows with a certain condition, but we don't want to fully filter them out of our query. If we were fully filtering those rows out of our query, we would put that condition in our where clause. If we want to still have that count, or that count of a subgroup, but still have them in our overall query, that's when we're using our case. All right, so this is our case as we did it last time, right? We're counting lines of dialogue of a specific character. We want to know all the lines of dialogue overall still. First, if you want to use this use case all the time for things like percentages, as we just did. All right, your case statement may or may not have an else at the end. All right, so this one does not have an else. It just has a when, then, end. The one that we just wrote right here has a when, then, has another when, then. You could have infinite when, thens if you had a bunch of data to clean up. I've written queries where I do a bunch of sort of when, thens for like every different typo that appears. And then this one does have an else because it's just a few things we're fixing, and then otherwise we want it to be filled in. Okay. My else is not required. I just got to make sure it has this end keyword right at the surprise end. Okay. We also just talked about joins. Okay, so left join and join accomplish similar things. Join is just going to grab things that exist in both tables. Left join is going to keep your first table intact. Okay. And then the last piece to know about joining is just whether your column names are the same. So if you're doing a couple of queries yourself first, it's useful to make that column name spelled the same. So if I were designing the Olympics data set, I would have called it code athlete in both tables so that I could have just said using code athlete instead of having to remember that in one table it's this name and the other table it's this name and I got to put an equal sign in between. Okay, so you may have to do that based on your data source. If you're the one making the column names, I would advise making them the same across your tables if it's going to be that column that's joining. Okay, and then the last thing that we just did is comparing a couple of strings. So we did I like in our rowing version of this, and your I like, the I means case insensitive. So if you don't know if it's how exactly something's capitalized, you want to use this. And then our percentage signs at the beginning and end of that text will tell us if that text just exists anywhere in what I'm looking at. So for example, let's say you have a list of email addresses. You want to know everyone who's still using Yahoo Mail, so who has their email at yahoo.com. You could do email I like parentheses percentage Yahoo percentage parentheses or percentage quote, and that would tell you how many of these people there are. Question?
Can you differentiate between case and when? Like, again, was it where or like said?
Yes, okay, good. So up here, let's go back to our example with case. Did I delete my case example? Oh, here we go. Okay, great. Yeah, so here I still have my information about all these people who are not IS medalists, but in this particular column, I do not. So if I had updated this to say where, my where would always come after my join. So let's say I said, where is medalist? Instead of having it up here, then my percentages are gonna get wonky because now I've filtered my medalists out of both my columns. So my percentages are always 100%, meaning everybody, this where is filtering it out of the entire table. This case is just saying, just in this column for this one time, does it meet this condition or not? So when I take this guy back out, fantastic, it put things in a different order, but my number of medalists stays the same, but my number of athletes goes back up to include those non-medalist folks. So where is filtering from your entire thing? Good question. Other questions? Okay. Let's see how we're doing for time. Okay, I think we don't have time to fully go through this last chunk. I have a few more sort of examples here that are sort of a set of what we just did similarly. So I'll just kind of talk through what it is, and if you want to give it a try yourself afterwards, feel free. But I'll just kind of walk through this. So this is looking at rowing volleyball data sets, okay? So anytime you're kind of starting with a new question, new area you're looking at, you're going to do these same queries. You're going to look at the first few rows, look at it with your eyeballs, understand what the columns are, and you're going to find out how many rows are in your data set just to get a sense of the scale that you're working with. Okay, so anytime you're working with data, you're going to do that. The next thing in this project is to say, of all the rowing results, which country competed in the most races? You've got a typo, competed in the most races. How many athletes competed on those teams? Okay, so just by looking at this question, you can tell that you're going to need to join in some different information. For example, we have a data set, which is our number of teams. If you go and look in your data browser, on our teams rather, we have teams data, which we haven't used yet, but this is going to tell you which team and which athletes are a part of which team, all right, and in which discipline. So obviously there's a variety of team sports in the Olympics. So to answer questions like this, we'd want to do a set of data modeling queries similar to the set that we just did, looking at this teams data. All right, so this is just sort of like another case study of how you could do some data modeling to figure out these sorts of questions. All right, I think maybe for this last one, maybe we'll skip down to 7. So we were just talking about case statements and we've got a few more minutes, so I think this would be good practice. So last thing we're gonna do for today is create a data model called medals total, right? This is something that probably the press would want to use a lot, right? To report on which countries earned the most gold medals, most silver medals, most total medals, etc. So we're going to make that information super easy for them based on our medals data set, all right? So if we look in our data browser, we have metals data. All right, and you'll see we have country code, metal type. So we essentially want to do some summarizing of that information. So the result we want to end up with is one row for each country, a column for the number of gold medals they have, a column for the number of silver, a column for the number of bronze, and a column for the total. All right, so since we haven't looked at the metals data set yet, what you should be doing first is typing select star from metals data, if I can spell metals. Let's see, limit 10 or 20. Spell metals correctly. Oh my God, I forgot the from. There we go. Okay, great. So you should start with something like this. Eyeball to yourself, okay, which column tells me if it's gold, silver, or bronze? Which column tells me the country? And how would I get this data set grouped down to, hint, grouped down to a data model with one row per country that then has these 4 columns: gold, how many silver, how many bronze, and our total. For those how many gold, how many silver, how many bronze, you might need to use a case statement. All right, so always start with the simplest query that you can think of. See if that runs and go from there. I'm gonna give you all maybe 3 or 4 minutes to take a stab. Give me a wave if you get stuck.
Well, this turns out does not exist.
Well, the table that we're looking at is metals data. I'm not sure what metals total is. It looks like that's something that has 0 columns.
Oh, yeah. Probably.
Yeah, it's just because that's one that has rows. Yeah. All right, if you're feeling stuck on your case statement, remember you're looking for logic like in the case that the metal type is gold metal, then count it. Okay, that would be our gold medal count. In the case that the metal type is silver, then count it. Be another column. All right, so think about how your case statement might look.
cái case là cái case mà thấy à, nó nằm trong những quên trong cái sẽ là case
All right, okay, let's talk about how to get our summary by country. Anybody have a case statement they want to take a stab at? Got it? Okay. Let's start with the simple part. So we know we want our result to have country. So I'm going to start with country. And we know we want it to have total metal count. So total count I would get with count star. Since our whole table is metals here, I can assume that counting everything is just counting all the metals. So I'll call this something like total metals. And since I've got a count, if I just run this, I'll get an error. It will tell me country must appear in the group by. Good mental reminder. I should add a group by country. Okay. And so just right off the bat, pretty simple. I've got 2 of the 5 columns I want to end up with, right? I've got country and I've got total metal count. All right, again, always start with the like very simplest parts. I know I need country. I know how to do a total count. Got my error message, told me to add a group by, added my group by, that's how I got here. All right, so you want to start really simple and be adding pieces. Okay. All right, so I want to add my gold metal count. Which column tells me which type of metal it is? Metal type, fantastic. It's great to have your columns be named useful things. Okay, so when metal type equals gold metal, then so I'm essentially want to add my count. I should put my count here. In this case, I'm counting. In this case, I'll just count, say, the country column. Doesn't really matter. I could pick any. And I'm going to call that gold metals. All right, hide my little data browser so you can see better. All right, so count case when my condition, when the metal type is this type, then count something, in this case, just count some with anything with the country filled in every row and as gold metals, right? Let's run that and see if that works. I'm gonna get an error. All right, what is my error? It says parser error, syntax error at or near count. All right, so some of you might have gotten this error already today. I'm gonna look near this count. It has a comma before, it looks all good. I'm gonna look near this count. It does not have a comma before. So you start writing the longer lines, easier to forget the commas, right? For my, that, add my comma back in, boom, it's added. All right, now we're gonna see that all the countries have 0 gold medals, including the United States, which I watched the Olympics from here and I'm pretty sure we have some gold medals. What is up with that? The way I would solve that is I would go back to, I deleted it, so I'm gonna recreate it. Just select star from my data set and look at it with my eyeballs again. All right, so select star from my metals data. Let's just go look at this. Gold medal, looks like a typo. I spelled it metal like the metal, not metal like the metal, you know? Okay, great. When I fix my spelling, boom, there we go. Okay, now I'm seeing most countries have a couple gold medals, sounded good. Okay, great. So ran into a couple errors, but I fixed them. And now I'm part of the way to what I want. I just want another column for silver medals and another column for bronze medals. So since I can copy paste, I'm going to copy paste this line 2 more times, but I'm going to change it in one to silver. And I'm also going to change my column name to silver. And then here I'm gonna change it to bronze, all right? Change it to bronze here as well. I'm gonna double check my spelling really quick since I screwed that up before. Silver medal, bronze medal. Okay, looks like I spelled those correctly. Added commas in between. And let's run that. Okay, looks the same. Belgium still has 3 golds and 10 in total, but now it's got 1 silver and 6 bronze. All right, I can also gut check that this is working correctly because I can, in my head, add 3 and 1 and 6 and confidently get to 10. So it seems like things are working. Cool. So this now is a data model. All right, so this is metals total. All right, I could name it something else. It might have auto named itself data frame 15 for you. Looks like I might have already named it. This is now a data model. This is essentially something you can access, you can query from. All right, so now if I'm a journalist and I want to know which countries earned at least 1 gold medal and no silver medals, I can write a very simple query because we've already done the modeling work. I can say select star from medals total, where gold medals greater than 0 and silver medals equal 0. All right, let's try that. Boom. Right away, I get these 13 countries competing in the Olympics. And I see that, you know, Morocco, Dominican Republic, Austria, a bunch of countries got a gold medal, but no silver. And there's, first, that's my news headline for some reason. I can write about that. So this is super easy for me or somebody to get to quickly since I've already done this work of doing a little bit more complication. So on a bigger scale, this is how data modeling works. So I spend a lot of my time at work writing maybe dozens of these from a bunch of different data sources that come down to one model that's really easy to query from, like student GPA, like medals by country. So that's kind of what you can do with SQL. That's how it's most commonly used. All right, so hopefully that gave you a good taste of what to expect if you get into writing more SQL. That's kind of how it'll work. So start simple, start adding parts, read your error messages. All right, they're actually pretty useful in SQL compared to other things. So on our last minute, just want to remind you about our upcoming sessions. So next week, we're going to not do any SQL. So if you're tired of SQL, come back next week. We'll do Python. All right, that's what we'll do for our next 2 weeks. We'll be getting into, again, if you've never touched Python, if you need a refresher, you played with it a little bit, you are welcome. Please come. Python can do everything SQL can do plus more. All right, so we're kind of like just adding on to the tool belt as we go. And then in that last week, so we're going to skip a week because I'll be out of town. But in that last week, we'll put our SQL and Python knowledge together. If you're specifically interested in data modeling, the slides will get posted to the Digital Lounge after this. But I have a sort of article here on like how to think about data modeling. So how you think about structuring what your rows are, what your columns are. When you're doing those queries, you're essentially trying to anticipate what questions people will ask. And then, yeah, a couple more learning links, things you might be interested in if you want to keep learning SQL yourself. Those are all linked on the same that guide website. There, I put like a learn more button at the bottom, and I put some links to stuff that I think is helpful that you might enjoy. Cool. So that's all we got for today. I'll hang out for a couple more minutes if anybody has questions. Otherwise, hopefully see you next week. Thanks, everybody.
Get back to the. Do you mind like scrolling down here?
Yeah. Okay. Yeah.
For the equestrian so separate between the.
Yeah, you probably have left your column name the same, but your grouping by. So if you're grouping by this. Yeah, so you're still, so that's the cleaned up column, but you're still grouping by them. If you group by disciplines clean.
Oh.
Yeah. And near the when. Looks like.
You go.
Here.
You.
Single quote.
Thank you.
Oh, okay, I guess that's it. Okay, no space. Good note.